In this episode, we rebuild our trusty club glider cockpit, explaining the layout, wiring, and design into a true pride and sleek showpiece of our fleet. Our workhorse, an SZD-51, affectionately called Junior, has clearly seen many years of service. This aircraft is used far more than any other, and it shows. Over time, instruments have been replaced, renewed, and added multiple times. One could, of course, complain that at least 7 different rusty screws are holding the cockpit together. But the fact remains, it is still fully functional and airworthy. So why invest money at all? There are 3 solid reasons. First, we have received a new flight computer. It needs to go into this aircraft, as it records IGC files, provides a significantly faster variometer, includes the Hawk function with 3D wind calculation, and displays airspace information. Second, the cockpit should create a genuine wow moment for young pilots stepping into a cockpit for their very first solo flight, while also helping to attract new club members. And third, even experienced pilots tend to take better care of an aircraft when it looks brand new. Besides, what else would we do during the winter? And what instruments do we actually need? Well, the mandatory instruments are an airspeed indicator, an altimeter, and a compass. That is non-negotiable. In addition, we want a variometer, which is absolutely essential. Since this aircraft is approved for limited aerobatics, a G-meter is also required. As this is an aircraft in which young pilots will fly their first cross-country flights, a transponder should definitely be installed. A radio has effectively become indispensable as well. The Junior also features a practical ventilation inlet integrated into the instrument panel. And while we are at it, we can integrate the remote control for the ELT as well. Since we are already investing this much effort, we decided to completely rebuild the internal wiring for power, air, and batteries, including an integrated solar charge controller. A new instrument panel shell is quite expensive, so we decided to machine only a new carbon fiber front plate and bond and bolt it to the existing structure. This results in excellent rigidity, combined with a clean, racing look. The new panel will be machined rather than drilled, which should provide higher precision. Finally, there will be 4 circuit breakers, a USB socket for external devices, and a charging port. These will be placed in the lower base section, where they do not need to be accessed frequently. To be honest, this was a really tricky part. On the one hand, the arcs and curves follow almost no true circular geometry at all. On the other hand, we failed several times when trying to measure it manually. The only fixed references are the height and the width, at least that much. But for an engineer, nothing is too difficult. There is an app that allows a 3D reconstruction to be created from many individual photos. So that is exactly what we did. And voila, here is the cockpit in 3D. This is not yet a template or a proper construction drawing, but it is the first essential step. We absolutely need this in order to machine the cutouts on the milling machine. So we take the 3D scan, clean it up by removing unnecessary artifacts, and then, in a CAD environment, in our case Blender, we create a cross-section through the front part. This gives us a contour that is already a very good approximation. The many points along this line are then smoothed to achieve a clean, continuous curve. Finally, we scale the entire shape to our fixed height and width dimensions. Not easy at all, but it worked. Positioning the instruments turned out to be tricky as well. From the front, everything looks fairly straightforward, but on the backside, it is a completely different story. The instruments are almost like icebergs, slim on top, much bulkier underneath. So whenever you think you have found a good layout, the backside quickly proves you wrong. It took us 7 iterations to get it right, which also meant quite a few attempts at the milling machine. Our recommendation: make paper templates and move them around like pieces on a chessboard. What works beautifully now is that thanks to the precise design, all mounting holes are exactly where they should be. That makes the final assembly genuinely enjoyable. One more thing. We wanted to reuse the older instruments, which came with rather unusual screw dimensions. We drilled those out and will now fasten everything using 4mm black oxidized Allen screws. Naturally, they are made of stainless steel. We do not want to confuse the compass. Our junior pilots have always looked with a certain amount of envy at the beautifully equipped cockpits of high-performance gliders, so we decided to do something about that as well. Due to a chronic lack of funds, we organized a small collection to finance an interior lining. No walnut burl and finest leather, of course, but Alcantara does the job very nicely. This is a custom-made solution, which requires accurate patterns. Unfortunately, there was no existing template for this aircraft, but we managed to create one ourselves. The patterns, including the headrest, are sent to the manufacturer, the desired pocket positions are marked, and a few weeks later, the finished panels arrive. These can be easily installed using Velcro. The manufacturer offered a very wide range of colors and surface finishes. Electricity? That's easy. Just connect the battery to the devices, and that's it. Yeah, okay, maybe add a fuse. Sure, 4 fuses, since there are several devices. Oh, 2 batteries. Then we need a selector switch and a charging port, or 2. Wait, which now? And the solar panels? Do they charge only the selected battery? How many devices do we actually have? Okay, we need to map this out. Each battery has an LX-nav battery monitor. These are excellent. You can read charging current, discharging current, and a whole lot more via Bluetooth on your smartphone. No crawling around with a meter needed. The charging port is double equipped. The charger feeds both batteries over 2 separate lines, regardless of which battery is in use. Similarly, the solar panel's charge controller charges both batteries and has 2 separate charge circuits. From there, a switch alternates between the batteries and power is routed to the consumers: radio, transponder, flight computer, USB, canopy lights. Everything runs through 2 neat power distribution rails. Of course, everything is protected by fuses. We opted for Clixon fuses, which are circuit breakers that don't need replacing. One final crucial point: use the correct wires. Here is the complete schematics. Maybe we change here and there a little bit, but the main points are clear now. In part 2, we take you through the full assembly and show you the finished result.